as to what would be covered on your test on Friday, so I thought it might be good to go through just a basic overview of what we learned throughout this first unit. My purpose in this video is not to give you an exhaustive list of different topics or problems to study, but instead it's to refresh your memory on what we learned so that you can feel confident that you know some of the topics and also feel reassured that you have now remembered some topics that you might have been a little bit shaky on. So taking a stroll down memory lane, the first topic we talked about was labeling in geometry, and we talked about points, lines, and planes. So first thing we talked about was point, and just remember that your points are labeled with this uppercase letter, and you can use any letter in the alphabet. The next topic, or the next term we talked about were lines, and just remember that lines go on forever, so we can never measure a line. And just remember that you can label a line in two different ways. So you can either pick 2 points on the line. So here we could pick point A and point B, and we would label it AB with a double-sided arrow over top. Or you could pick this lowercase letter m and say that this is also line M. Remember that order does not matter when you're labeling a line. So you could have said line AB or line BA or line M. Then we talked about planes, and I think the trickiest thing about planes was figuring out how to label them, and you'll notice there are 2 main ways that you label a plane. One, you could pick a capital letter that's not a point. So you'll notice that letter P, right here off in the corner, doesn't reference a point, so you could say that this is plane P. Or you could pick 3 points that are found on the plane that are not all found on the same line, and you could use those 3 points to label the plane. So what I said in class was that you want to connect your 3 points and make sure that they make a triangle. And you need to be wary that occasionally diagrams will have points that are found outside the plane, and you don't want to use points that are found outside the plane. So make sure that all your points are found within the plane. So I think what I referenced in class was that I said, if your paper is the plane, the paper that you're writing on right now is the plane, your pencil is sticking out of the plane. So you wouldn't use the eraser point as a point to name the plane of your paper. Next we talked about a segment, and segment's very similar to a line except that it does have 2 endpoints, so we can measure a segment, and we actually moved into segment length after this topic because we realized that segments can be measured, and we talked about adding segments together. Your next topic or your next term was rays, and rays are very similar except that you have 1 endpoint, and then the ray extends infinitely forever in the other direction. And what was important to remember about rays was that when you label them with that single-sided arrow, the arrow needs to always be pointing towards the right. So you always want to start by labeling your endpoint. So here we have endpoint A, and you want to label your endpoint first and then say, so it's ray AB with your one-sided arrow pointing to the right. And then down here, you'll notice that we have endpoint B. And so we start by saying this is ray BA. And it looks, it's almost a little counterintuitive to have a ray that's pointing to the left, but you're labeling it and showing that the label looks like it's going towards the right. So even though this doesn't look like it's necessarily right, just remember that your labels always have to point towards the right. Now, opposite rays were very, was just, you stick two rays together. Opposite rays are the same thing as a straight line or a straight angle. So 180-degree angle. And what I said in class was that, say you were standing up and you stuck your arms out so that they were, extended as far as they could horizontally. And what you would have is you'd have an opposite ray where your 2 hands, your left and your right hands, would be like point A and point B. And your head would be like point C. And so your arms would be extended at a 180-degree angle, and your head would be that endpoint that they share. And now collinear and coplanar were just 2 terms we talked about. Remember, collinear only references points, and coplanar references points as well as lines. And I just want to highlight 2 postulates that we touched on. So just remember that when 2 lines come together, they come together at a point, which is different from when we have 2 planes. So remember, when 2 planes come together, we have this yellow plane and this green plane. They come together at a line. And this is an example of something that you might see on your test. Remember, I'm going to be looking for points and lines of intersection, different ways to name points and lines, and then whether or not certain lines and planes are parallel, perpendicular, or neither, are all fair game for Friday. Then we moved into segment addition, and what we started out with was looking at number lines, and we did a little refresher on absolute value, But our purpose in doing that was to remind you that distance is always going to be the difference between two coordinates. And whenever you're working with distance, always remember that it can never be negative. So that was one of the most commonly made mistakes I saw, was that a lot of you forgot to work out or some of you, not a lot of you, forgot to work out your absolute value once you had found the difference. And just remember that distance can never be negative. Here we have a slightly more difficult problem with segment addition. So that's what we were building up to, is we needed to solve backwards and do some algebra that involves these segments. So what we have is we have a segment that's split into two different parts. We have ST and TU. And what we know is that when we put ST with TU, it comes together to give us SU. So we are going to, and I'll actually work out a little bit of this for you, but basically we know that ST plus TU equals SU. And all we're going to do is we're just going to substitute what we know. You'll see at the bottom it says that ST equals 3x plus 3. And that TU equals 2x plus 9. And SU, the entire segment, equals 32. So we're just going to substitute in for what we know. And then we need to combine our like terms on the right, or on the left. So we have 5x plus 12 equals 32. You need to subtract 12 from both sides. So you get 5x equals 20. And then we need to divide both sides by 5, and we get x equals 4. Now to find the actual lengths of those segments, we need to plug back in. So we need to substitute our x value back in. And so we'd have 3 times 4 plus 3, which is 12, plus 3 is 15. And 2 times 4 plus 9 equals 17. And what I said in class is that a way you can check it is you can say, okay, I know ST and TU should add up to 32, so let's add it back up together. And we say that 17 plus 15 equals 32, and we are right. So we did it correct. Okay. So, and this is just another example problem that we did. Actually, after we did segment addition, we moved into angle addition, which is almost the exact same thing, except that we are using angles. And this actually highlights a problem that I touch on in a supplemental video on angle pairs. So you'll notice that RQT is a straight angle. And so what we know is that RQS and SQT have to add together, and when they sum together they make a 180-degree angle. So you would work this problem out very similarly, except that the total of these two angles together is 180 degrees. And once we got angle addition under our belt, we worked with vertical angles. And so what we need to remember is we worked with angle pairs, and our first angle pair was vertical angles. And basically we form vertical angles when lines are intersecting. And so what ends up happening is that angles that are across from each other are going to be congruent. So this angle where my cursor is right now would be congruent to this angle right down below it. And the angle on the left would be congruent to the angle on the right. So just remember that they're always congruent. Okay, and then we talked about complementary angles, which should be a review for middle school math. But basically, complementary angles are angles that sum to 90 degrees. So there's a couple examples. You will be responsible for tougher problems than just figuring out, okay, 50 subtracted from 90 is 40. You will be responsible for tougher problems, maybe some word problems, maybe some problems with algebra. But just keep this in mind that complementary means sum to 90. Very similarly, supplementary means that we have two angles that sum to 180. So here's an example down here. We've got 50 degrees and 130 degrees. If you were to add those together, you'd get 180 degrees. Linear pairs basically are a special type of supplementary angles. They are supplementary angles that are adjacent to each other. So they're right up against each other. All right. So, and like I said, they're supplementary, so they add to 180. Now, angle bisectors are just a ray that cuts an angle into two smaller congruent angles. And so if we look down here, we've got a larger black angle, and it is bisected by the orange angle. Let's say, for example, we knew this smaller angle was 30 degrees. If we're bisecting, that means we have to cut in half so we get two equal angles. So if this angle is 30 degrees, then this angle would have to also be 30 degrees. And then a way we would find this black angle is we would just double this 30 degrees, or we would say, 30 plus 30 equals 60. So the whole thing would be 60 degrees. After we worked through some angle pairs, we moved on to, actually went back to midpoint and distance. So we talked a little bit more about midpoint distance, especially as to how it pertained, how it was important in the coordinate plane. So we worked through a couple formulas. This one should be pretty familiar from Algebra 1. Remember to go back and study those problems that involved ratios and the problems that involved finding an endpoint. A lot of them were trickier word problems just because they were embedded in another story. But just go back and make sure you review and you look over problems that are about finding an endpoint when you're given one endpoint and the midpoint. There's distance formula. This one shouldn't be too hard. You will be responsible for committing all these formulas from memory because you were expected to have them memorized in an earlier math class. So you do need to take some time if you've forgotten them over the summer to remember these formulas because they won't be given to you on test day. It shouldn't be too hard. Just pay attention to what problems they're asking for, and you should be able to apply the formula correctly. And then the last topic we talked about were transversals. So we actually did this on Monday on Tuesday, I guess, before your test. And basically, when you have a transversal, you've got a line that's crossing over two other lines. The lines don't have to be parallel. We worked with angles when they were parallel, but they don't necessarily have to be. So this yellow line is your transversal. Now, this is some real-life examples to help you think about this, but your red and blue lines on the piece of paper you're writing on. If you look at tiles on the floor, you've got transversals all over, and just various other examples. And then our exploratory activity that we did on Tuesday was we looked at the 8 different angles, and what we said was that there were some unique pairs. And the ultimate result of this was that we found that in a diagram like so, there are only 2 types of measurements, okay? There would be your acute measurement and your obtuse measurement. And so every angle in this diagram is either congruent to or supplementary to angle 1. So for example, if angle 1 measured, let's say it's 70 degrees, then angle 3 measured 70 degrees because they're vertical angles. Angle 5 would measure 70 degrees because angle 5 is its corresponding pair. Angle 7 would measure 70 degrees because angle 7 and angle 1 are alternate exterior angles. And then we would look and we say, okay, 1 for our linear pairs, they make a line, they come together with a straight line, so they would be supplementary. So we would subtract 70 from 180, and we'd say angle 4 is 110. We'd also know that angle 2 is 110 because 2 and 4 are vertical. We could say that angle 8 was 110 because 4 and 8 are corresponding, and then 8 and 6 are also going to be 110 because they are vertical angle pairs. So that takes us through the conclusion of our recap. If this is just a basic recap, so if you have any questions, feel free to bring them to class or after school for after school tutoring. Thank you.